Let us prove this theorem. If two segments from the same external point are tangent to a circle, then they are congruent. A proof of this theorem is presented in one of the videos in this channel. Please watch that video. This is another proof I want to suggest. Let us draw a circle. This is the center of the circle. Let us name the center O, and let us name the circle circle O. This is a segment tangent to circle O. Let us name this segment tangent segment PA. This tangent segment PA is the tangent to circle O at point A. This is another segment tangent to circle O. Let us name this tangent segment PB. This tangent segment PB is tangent to circle O at point B. As we can see, these two tangent segments, that is tangent segment PA and tangent segment PB, comes from the same external point. The external point is point P. Given circle O and tangent segments PA and PB. Prove segment PA is congruent to segment PB. We are going to prove this theorem using a two-column proof. In the first column, we are going to write the statements, and in the second column, the corresponding reasons. For statement number 1, circle O and tangent segments PA and PB. The reason given. For statement number 2, we are going to draw line AB. So this is line AB. It is passing through point A and point B. This line AB is actually a segment. So the reason, line postulate, there is exactly one line that passes through 2 points. The 2 points are point A and point B. Let us look at the figure. Let us name this angle 1. And let us name this angle 2. This is a secant, and this is a tangent to circle O. So we can say that the measure of angle 1 is equal to 1 of the measure of arc AB. And the measure of angle 2 is equal to 1 half the measure of arc AB. So for our third statement, we have the measure of angle 1 is equal to 1 half the measure of arc AB, and the measure of angle 2 is equal to 1 half the measure of arc AB. The reason, if a secant and a tangent intersect at a point on the circle, then the measure of the angle formed is equal to 1 half the measure of the intercepted arc. This is a theorem. The proof of this theorem is presented in one of the videos in this channel. Please watch that video. In statement number 3, we said that the measure of angle 1 is equal to 1 half the measure of arc AB, and the measure of angle 2 is also equal to one of the measure of arc AB. So for statement number 4, we can say that the measure of angle 1 is equal to the measure of angle 2. The reason, transitive property of equality. If the measure of angle 1 is equal to the measure of angle 2, then we can say that angle 1 is congruent to angle 2. So for statement number 5, we have angle 1 is congruent to angle 2. The reason, definition of congruent angles. According to the definition of congruent angles, if two angles have the same measures, then they are congruent. Let us look at the figure. We said in statement number 5 that angle 1 is congruent to angle 2. So we can say that segment PA is congruent to segment PB. So for our statement number 6, which is the final statement, we have segment PA is congruent to segment PB. The reason, if two angles of a triangle are congruent, then the sides opposite these angles are congruent. This is the converse of the isosceles triangle theorem.